Okay, so this is us carrying on with the addition formulae. Please, if you haven't attended a proper lesson with me in school yet, can you wait until you have before you start this work, because we're going to start this topic together and this is just carrying on, so it won't make sense unless I've seen you in school. Right, so all we're doing is extending what we've already done. So use the addition formulae for sine or cos to write each of the following in the form sine of x plus or minus theta or cos of x plus or minus theta, where theta is between 0 and pi over 2. So the first thing to do is to look at the question. Now you might want to think, so ignore the green for a second, I made a mistake so I'm going over it again. You might want to think, oh well, that's sine of a plus b, but it's not, because it's sine of x plus cos of x, not sine of a plus b like we would see it up here. So please, you can't use an addition formula for it in this form. So the first thing we can do here is to multiply these out. So 1 over root 2 times sine x is 1 over root 2 sine x, plus 1 over root 2 times cos x is 1 over root 2 cos x. Now we're going back to what we did in school, where we're saying, so I'm going to be, it's just snap. So can I use the addition formulae or the subtraction formulae for sine, which are sine cos plus cos sine, or sine cos minus cos sine? Or can I use the addition or subtraction formulae for cos, which are cos cos minus sine sine and cos cos plus sine sine? So which one does this match? It's important to note that we want it to be with the x at the front. So for us, we need x to be a when we're matching them. So yeah, that's an important thing. We want x to be the a, not the b term in the addition formulae. So if I match these up, I would say that for me, this one matches sine a cos b, because there's my sine a there, plus cos a sine b, because there's my cos a there, because I'd said a has to be x has to be a. Sine a cos b plus cos a sine b is the addition formulae for sine. So that's going to be in the form sine of a plus b. So I've matched them up. If those two match, then these two must also match. So I'm now left knowing that cos b, oopsie, can't even write it, cos b is 1 over root 2. If I inverse cos 1 over root 2, and we are in radians, so if I inverse cos 1 over root 2, I get pi over 4. To find my second solution for cos, I make it negative, and then I'm going to plus or minus pi to each of those. But you can see that they'll take me out of the range. So the only one in the range is this one here. Okay, so b must be pi over 4 to be in the range. If I do the same on this side, I know that sine b is 1 over root 2. If I inverse sine 1 over root 2, I also get pi over 4. And my other solution for sine, I would do 180 minus it, so I would get 3 pi over 4. And again, the only one that's in the range is this one here. Now, it could be that there were 2 in the range, so let's just say all of these solutions lay in the range. You would choose the one that appears in both. Okay, so I would choose this one because it is true for both, and b has to be equal to b because they're the same thing. Okay, so look for the overlap, check that it's in the range. Once I know that, I know that it's the addition formulae for sine of a plus b, so I can write that as sine of a, which is x, plus b, which is pi over 4. And that's the end of that. Okay, so expand them, place snap, work out the value of b or a or whatever it is that you're missing, and then put them back into whatever formulae your game of snap corresponds to. So I would like you to try that for this one here. Okay, so if you pause it now, give it a go for this one here, but please leave room because we are going to come back to look at this again. So leave some space in your book, try it for that one. Off you go. Okay, so I will just slide, that's my work solution for that one there. So the one that I asked you to do, this is the answer for. So check that you have followed that through and that you're able to get it correctly from the work solution. but I want us to go back and look at this one, please. Right, so I did it this way, but I could have said, so I'm going to put a line around here because I'm going to be looking at it in a different way. We're still looking at this question, but in a different way. I could have said, when I expand it and get this, because it's addition, addition is commutative, so I could have instead written this one first. So I get 1 over root 2 cos x plus this one, 1 over root 2 sine x, because that is the same as that. If I had written it this way, I would have matched them up differently. Remember, x has to be a, so I would have said here, I've got cos a. The only addition formula that starts with cos a is cos a cos b, plus that would be sine a sine b. And that is the subtraction formula for cos. So that would be equivalent to cos of a minus b. That matches that, which means those two must also match. Okay, so if so I know from this side that cos of b equals 1 over root 2. I could inverse cos that, and I get pi over 4, or minus pi over 4. I know on this side that sine of b is 1 over root 2. I could inverse sine this and get pi over 4. There's 3 pi over 4. And of course it would have to be those ones, which is exactly the same as what we've got over there. But this is the subtraction formula for cos. So when I put my value of b that I've worked out back into here, I am going to be left with cos of a, which is x, minus b, so minus pi over 4. So how can that be equivalent to that? How can I have two different correct answers for the same thing? And the answer for this is cool. Very cool. You're going to be amazed, shocked, delighted, all of those things. So if I think about my sine graph, here it is. If I think about my cos graph, I'm always rubbish at drawing. Here it is. And so I'm going to be in radians here. So if I look at particular things which will have the same value, my answer is going to become clear to me. So if I look at this point here, which would be sine pi over 4, I can see that that point on the cos graph is here. Oh, it should be on the, I've drawn it rubbish. It should be on the axis, which is equivalent to cos 0. So that point there has the same value as that point there. If I look at this point on my sine graph, so sine, oh, I'm such a fool. It's not pi over 4, it's pi over 2. Sorry, sine of pi over 2 moves over to cos 0. If I look at this point, which is sine pi, I can see that that is equivalent to this one here, which on my cos graph is cos of pi over 2. Okay, so that is the same as that, that is the same as that. And if I carried on in that way and matched them up, I can find a relationship between sine of something and cos of something. So if I said I had sine of x, so if I let that be x, well, how do I get from x to 0? Well, it's x, take away, how do I get from pi over 2 to 0? I take away pi over 2. If I look at this next one, if I said that was x, sine of pi, so that was x, how would I get to pi over 2? Well, it would be x, which is pi, take away pi over 2. So actually, the sine graph is a translation of the cos graph. What we do is to get from, if we've got something in cos, we take away pi over 2 to make it to sine. So if I look at this here, I've got sine of x plus pi over 4. Well, how do I turn that into a cos? Well, I have cos of it. If I consider this whole thing my x, it's cos of whatever that is. But then I need to subtract pi over 2. And if I had cos of pi over 4, take away pi over 2, oh look, what have I got? cos of x minus pi over 4, because the cos graph is a translation of the sine graph and vice versa. So although they look different, they're actually the same because of the translational symmetry of the graph. So that's interesting. I think it's interesting, but then I am a maths teacher. Okay, so that's that example done. Did I have another one for this lesson? I can't think. Hang on a sec. Maybe I did. Right, that's what we've just done. Oh, or did I? Is that? Sorry, I've split this into 2 lessons and now I'm at oh no, that is this lesson. Okay, so now I'd like us to solve these. This is another type of example that we could do. So calculate the exact value of tan x, given that tan of x plus x minus 45 degrees is the same as a quarter. So this is the subtraction formulae for tan. So you know that tan of a minus b is, oh, what is it, tan a plus, I've got all that flap now. Tan, yeah, it's tan a minus tan b, sorry, forgot that for a second, over 1 plus tan a tan b. Okay, so that is the addition formulae, the subtraction formulae for tan. We've got x and 45 and a quarter, and we know that altogether it's equal to a quarter. So tan a is tan x minus tan b, which is tan 45, over 1 plus tan x tan 45. We know that is equal to a quarter. So that's my addition formula, which I've just written out for you, and I've put x and 45 into it, and I know that for my question it's equal to a quarter. How can I work out the value of tan x from there? The first thing I'm going to do is work out the value of tan 45, which you know from your exact values is 1. So I've got tan x minus 1 over 1 plus 1 tan x. And that's equal to a quarter. And solving that is relatively straightforward, because all you need to do is times the denominator up on this side. So you've got tan x minus 1 equals a quarter 1 plus tan x times the 4 up on this side. Bring all the tan x's to one side. So I've got 4 on this side if I take that one over. Bring all the numbers to the other, so I've got 1 here if I take that 4 over. So I've got 4 tan x minus tan x, which is 3 tan x, equals 5, and then divide by 3. So tan x equals 5/3. So the only thing that's the addition formula is substituting in the numbers there, and apart from that, it's just rearranging and solving an equation.